I would like to take a look at documentation again and take a look at the remove method. The remove method. Um, so here's a couple of interesting things that we can discover about the remove method. Remove index, remove index, remove by index. The first time we said remove to in whatever stored with index 2. This method actually returns back the reference to that particular element, right? So by saying remove in our project, we could have done this: string removed equals remove index 2. And we can just say, this string was removed from the list that we use. But I also can say that removed string such and such was removed, right? So that we actually can capture what we're removing when we're using an index. So quick run of this, right? So we say remove 2. If you recall, number 2 was this guy right here. So let me display them both. So when I say remove 2, it says that string world was removed. So I don't lose it. I can essentially relocate the reference and capture the reference of the remove string when I use an index, when I use an index removal. At the same time, when I specify an object to be removed, what comes back is the Boolean. Boolean was removed, right? So Boolean was removed equals this, and I can find out if the removal did take place. So was removed once, and here's an attempt to remove goodbye. Was removed. Was it removed or not removed? So each time I can also print this result to a string, and I can just simply say here plus was it removed, question mark, and add was removed to this output. And also the second time, the same thing. After attempting to remove, I can try to say, was it removed? Spelling here and there. So if we run it, so hello, which was originally this string, right? It did get removed, which is true, but goodbye was never present on the list, so it tells you no, it's false. It tells you that it was not removed. So quite flexible interface, I would say, that we have here with our array list, that we can do all these manipulations with individual elements, inserting them, inserting at a specific position, inserting at the end of the list, removing at a specific position, or removing a particular object, or even not removing anything at all, but you still can get an answer whether the removal took place or not. Is empty, that should be trivial, right? Empty or not, that's sometimes good to know. You can also not just add, right, but you can replace an existing element by saying set. For example, when we recall that we attempted to remove goodbye and goodbye wasn't there. So this is what we can do. We can say demo list set, right? And we can figure out. I mean, we can use like the very first element on this on this list, index 0, and we can set it to be hello, right? So this time we're actually uh, adding, not adding goodbye, but replacing hello with goodbye. And we can even like uh, display it very quickly somewhere here. I apologize that this demo program gets a little messy, but you know it does some work here. So demo list, um, after setting uh, first element to goodbye, right? So let's see how that looks like. Running it. So goodbye 1 2 3 4 5 after setting first element to goodbye, that is expected, and after attempting to remove goodbye, of course now this is true, that yes, it was present indeed on the list. So the set method of the demo list replaces the value, right? Replaces the value. Let's see if there are actually multiple versions of the set. If we look at, sometimes it's useful not to just look at this presentation level, but actually look at certain at the official documentation. So here's a set, and there's just one form of it. There's no overloaded other methods. It just basically says replaces, right? So it does replace. Replaces the element at the specified position in this list with the specified element. So this time, of course, the position should be legal, right? So if list is only 5 elements long, but you trying to replace the 9th element on that list, it will crash the program because of the illegal access. So let's see that if we can produce that here. If we try to replace a non-existing element like element number 100, right? Then if we run it, it does throw an exception. It basically says the range check here, the range check has failed, and it throws an exception. So there are ways to find out. Obviously, we have the size of the list to make sure that our index is within the legal boundaries here, and that, of course, is the size. So it's one of the ways to check. Or you can also catch the exception. But perhaps just checking the size is a good idea in case if you want to make sure that your index is safe. Get element simply gets a reference to a particular element. You can also search for the position of your object inside this array list by specifying what is the index of string such and such. In our case, we use an array list of strings. And since the array list is based on the underlying primitive Java array structure, of course there is this method to convert it to an array and give you an array equivalent of your array list, right? Again, if array list is big, doing something like that is an expensive operation because a physically separate version of an array is produced. So actually, let's check the documentation of this method as well. So to array, returns an array containing all of the elements in this list in proper sequence. what I am curious about returns an array. Um, the return array will be safe in that no references to it are maintained by the list. In other words, this method must allocate a new array. That's what I was trying to make sure. So it's completely safe for you to use because it's a duplication of what your array list already has. So just to make sure that this is confirmed, and that's what I thought this should do. Okay, so these are some of the common methods of an array list. Hopefully, they're quite convenient. The signatures of these methods are very short. So you manipulate objects, you manipulate indices, and sometimes you get this true or false indicator whether something did take place or didn't. So very convenient, I would say. Very simple, very convenient, and I can tell you this: ArrayList is perhaps in the entire Java world is the most popular container, right? Because it's just the first choice for many, many, many situations. So most Java programmers kind of remember this by heart and just know exactly how those methods behave and what methods are available.